Hello everyone, and a very warm welcome to Kognito Key. I am absolutely thrilled you're joining me today. We're going to jump right into a truly fascinating and honestly essential topic in computer networking. Today's explainer is all about demystifying IPv4 multicast addresses, so grab your virtual notepads and let's dive right into it.
Okay, picture this for a second. You are broadcasting a massive live cricket match, or maybe streaming a crystal clear high-definition video to thousands of users all across the country. Now, if your poor server had to send a completely separate data stream to every single viewer, one by one, your network would absolutely crash under that immense load. There's just no way. So, how do networks actually pull this off? How do they efficiently deliver just one single video stream to thousands of specific users at the exact same time without completely breaking down?
Well, the secret lies in something called a multicast address. Instead of sending data individually to every single machine, which, like we said, is a guaranteed recipe for a network crash, a multicast address is brilliant. It lets you distribute one single common data stream directly to a specific multicast group. And the best part? It doesn't matter if those hosts are sitting right there on your local network or if they're scattered all the way across the globe.
So, in the world of IPv4, where does this multicasting magic actually live? Right here, inside the Class D block. Now, whether your network uses classful or classless addressing, this really massive block of IP addresses, starting from 224.0.0.0 and going all the way up to 239.255.255.255, is dedicated entirely to multicast addressing. It is just this huge, reserved space built for one specific purpose: broadcasting to groups.
Now, because this Class D space is so vast, RFC 3171 methodically chops it up into exactly 8 operational blocks. You might actually want to grab a quick screenshot of this for your notes. We've got the local network control block, the internetwork control block, the ad hoc block, stream multicast, SAP/SDP, the SSM block, the GLOT block, and finally the administratively scoped block. It's a lot, I know, but each one serves a highly specific, vital purpose.
Let's look at how a few of these actually function in the real world. The local network control block, for example, is strictly for traffic within a single network. In fact, routers will literally refuse to forward these packets. But remember that live cricket match we talked about? That relies on the stream multicast block, which handles all that heavy multimedia traffic like audio and video. Meanwhile, the SSM block is just brilliant because it lets the receiver terminal say exactly which source it wants to pull the stream from.
Section 1. Choosing the right address. Limited versus large groups. Let's take a look.
So, if your multicast group is limited, meaning it's safely tucked inside a single autonomous system, you'd purposefully assign an administratively scoped block address. That keeps your data securely locked within your organization. But if you're dealing with a large group that's scattered far and wide beyond that system, you're going to utilize the SSM block. And you know what the best part is? You don't need any special permissions to use SSM block addresses. It makes life so much easier.
Section 2. Delivering multicast packets at the data link layer.
Let's start by looking at local area networks, like good old Ethernet, which actually natively support multicasting. As you probably know, an Ethernet physical address is exactly 48 bits long. Well, Ethernet brilliantly supports our multicast data by just splitting this address right up. The first 25 bits precisely define the physical multicast address, while the remaining 23 bits perfectly pinpoint the specific multicast group that the host belongs to. It is just beautifully efficient.
But wait, what if your data needs to travel across a wide area network? WANs usually don't have that native physical support for multicast, so networks rely on a really clever workaround known as tunneling. Think of it kind of like slipping a smaller envelope inside a larger shipping package. The network simply encapsulates the multicast packet safely inside a standard unicast packet. That way, it can pass right through the wider network without a single hitch.
So if there is one crucial point I want you to take away today, it's this. Multicast addresses are the ultimate key to delivering a single packet to multiple hosts efficiently across literally any network structure. Whether you're assigning administratively scoped blocks to keep things secure on a local corporate network, or you're using clever tunneling to pass streams through a massive WAN, understanding these IPv4 blocks is an absolutely vital skill for any modern network engineer.
Thank you so much for tuning in to Kognito Key today. I truly hope this explainer made the somewhat complex world of IPv4 multicast addresses feel simple and clear.
But before you go, I want you to think about this. With the massive global transition to IPv6 currently underway, how are these multicast concepts going to completely transform in a world with nearly limitless IP addresses? I would love to hear your thoughts, so let me know down in the comments. If you found this explainer helpful, please hit that subscribe button, give it a like, and share it with your fellow network engineers. Keep learning, stay curious, and I will see you next time.